Last year on the channel we built a simple kid's go-kart. I got in on the fun too, but I think I need one my size. Let's make it. I'm going to start by fabricating the rear frame hoop. Notice this is a long piece of 1-inch round tubing, and I want the whole rear frame to be one continuous piece. That's why I'm making it this way. I'll mark out locations for each of my bends, and the first ones will be S-bends like this to add some vertical dimension to the frame. In order to do this, I need to make two 45-degree bends really close to one another. Tall ceilings come in handy for this, and I had to prop up my bender stand to be able to clear the floor for the second bend. Not all benders will do this, and it took a little bit of figuring out to be able to do it with this one, but it came out nice on each end, so it's symmetric so far. Now I just need to make two 90-degree bends for the rear corners, and it'll be in good shape. It looks good. I'm going to flip it over and fabricate this upside down to begin. I'm building a little fixture with the Siegmund table here to be able to hold everything in place and reference off of while I build the rest of it. Because everything's squared up, I can just use the grid lines here to mark where I need to trim and cope the front edge. I'm just using a tubing notcher here to trim and cope it. I don't think I get as good of a cope with a tubing notcher like this as I do when I cut them by hand. However, it's quick and easy. Now I can make the front axle to fit in those copes. I'm going to bend the end a little bit on each so it'll be upturned, and then cut this to be parallel. This mitering chop saw has been really nice to cut these angles that aren't standard, and it came out really good. I'm clamping everything down, and I'm using these spindle mounts that I had left over from an old go-kart and lining them up using the grid on the table. With everything lined up, I can go ahead and weld the ends on and have my front axle. It's sitting in there nicely, and I'm happy with how everything's going together so far. Next, I need to make some bearing hangers for the rear axle. These will have a notch in them to be able to accept the axle and bearings, and I'm just holding in place with these genuine squares right here. A little bit of a tack, and it should be in place. I'll weld those all the way out. Now I'm going to put together the wheels and tires so I can assemble the rear axle. For the front wheels, I need to install bearings, and I'm just using this dimple die press that I built on the channel a while back, and it worked great to install those. Putting these wheels and tires together was a bit of a chore to get everything to sit right. I needed to install the tube and added some air, and then I could sandwich everything together and secure it with some fasteners. It came with stainless steel fasteners all around, but I found that those galled, and so I needed to replace them so that one of the fasteners, the nut, wasn't stainless steel if the screw was. I pinched one of the tubes and had to replace it, so be careful of that. Now I can turn my attention to the rear axle, and I can slide on the sprocket and the brake rotor and secure those in place. The actual bearings are sandwiched in between these sheet metal stamped pieces, and I thought the design of the locking collar was pretty smart. There's an eccentric outer diameter on the bearing and an eccentric inner diameter on the collar, so you rotate it till it'll slide together, and then when you rotate them, it locks it in place. I thought that was really clever. With the bearings installed, I can go ahead and slide the wheels on. Now, the way these wheels work, the shaft is machined down at the end, right where the threads are, so I have a large diameter on the inside of the wheel and a small diameter on the outside of the wheel that allows me to secure it in place with a nut, and that keeps it in place axially both directions. With the rear axle assembled, I can set the frame on here, and it's starting to look a little bit like a go-kart. This is the part of the project where things get pretty exciting. It's nice to see some progress. Those axle hangers dropped right over the axle, and then I can slide the bearings into place. With the rear axle in place, I figured I might as well go ahead and put on the front wheels so that this thing's a roller. They all fit pretty well. Next, I can put in a rear cross member. This cross member is going to allow me to put the engine mounting plate on as well as secure the rear brake caliper. I'll just tack it in place once I've got it in the right location. This rear cross member will just tack directly to the brake caliper mount, which allows the caliper to slide side to side with pad wear. I'll weld this out along the edge, and notice I'm having to push a lot of filler metal in. I probably should have used a larger diameter rod for this. Now I can turn my attention to engine mounting. The first thing I'll do is install the torque converter onto the engine. This allows the gear ratio to change similar to a transmission. It's similar to what you'd find in a snowmobile or a lot of ATVs and side-by-sides. I cut this engine mounting plate out on the plasma table, and I have it set in place here. It seems like it'll work okay. I'll remove the mill scale from this engine mounting plate so I can get a sound weld. Notice that I removed it from the center as well as the edges. The reason for this is I'm going to install a brace underneath, a little piece of material that's mounted the hard way so that it can't flex as much as it otherwise would. I need to weld this in place before I can actually put the engine mounting plate in, because it'll be really difficult to get up in those corners and weld once the plate is on top of it. Once I have this welded in place, I can go ahead and set the engine mount plate on and tack it on all four corners to hold it in place. Once it's tacked up, I can just run a couple of lap joints and weld it up here on the top, and I'll also weld it underneath to the bottom brace to keep everything nice and secure and keep the engine from flexing around too much. Next, I'm going to make a front bumper for this. This is going to be a simple piece that'll be straight along the front with two bends that 90 degrees at each corner, so it looks like it continues off of the frame rails that are there. Because these have short stubs on them, I can't fit it into my tubing notcher, so I'm going to cut the ends off using a vertical bandsaw and then go ahead and notch it by hand using an angle grinder. It sits nicely up on the front there, and the fit is pretty good. I'm happy with how everything's going together now. All of the welding so far has been TIG on this project. I could use MIG or even flux core for this and it would work fine, but I just like to TIG weld and I think it looks nice. So I've run into a bit of a problem putting this together. I didn't account for the size of the fuel tank sitting here behind the seat. So now, rather than having the back hoop come up right here, I'm putting my seat pad in place, and it's about 5 or 6 inches shorter, and I'm not the most flexible guy, so that's gonna make things pretty uncomfortable. I need to figure out a way to solve this. So if I slide the engine back, the torque converter runs into the back of the frame. And so that doesn't allow me enough movement there. One option would be to raise it up. And I've set the engine up on a 2x4, so it's 1.5 inches higher, and this gives enough clearance to be able to slide this back and clear the rear frame rail with the torque converter. However, I don't really like the engine sitting up this high, and it needs to be even further back when it's raised up higher. One option is going to be eliminating the torque converter here and just replacing it with the centrifugal clutch. But before I do that, I want to play with the orientation of this and see if there's some other way to arrange it. Even though this is drilled like Swiss cheese, none of these orientations are going to work for me, so I'm going to have to modify the torque converter to make this work. I'll mark approximate locations. I'll precisely measure it with the mill, but whenever I'm making a modification, I like to put a rough idea of where it's going to go, just to double check myself as I make it. Here's a trick for you when you need to measure the diameter of a bolt circle and all the holes are the same size. If I measure the diameter of one of the holes and then zero out the calipers, it'll automatically subtract that from the diameter I measure across the bolt circle there. Now that I've measured the diameter I need, I'll locate everything on the mill. I need to find the center, and this isn't the best edge finder to use in an inner diameter, but it'll be close enough for what I'm doing, as are the 2x4s that I'm drilling into. Now is the moment of truth, and it seems to fit really well on here. I'll go ahead and install it and torque everything to spec. Next, I can reassemble the torque converter itself. It has several parts, so these sheaves go together, and that changes the width of the actual pulleys here to change the gear ratio. That's how one of these works. It's pretty cool. With everything in place, I set the engine down and it seems to clear. So I think the problem is solved for us, except I need some new slots to mount the engine. I'm going to have to go old school and drill holes and then connect the dots together with a plasma cutter. You could just as easily do this with a jigsaw to connect the dots or some other tool. While everything's sitting nicely, I fabricated a hoop for the back of the seat and it clears the engine just like I'd hoped. Now I can turn my attention to the steering. I have my components and I've bent a hoop to support it up here, and I'm just playing with the location using some parts from the fixture table, and I think I got it sitting pretty nicely, so I can tack everything in place. I'll just put some light tacks on till I do an ergonomics check, and it seems pretty good. So I'll finish it out. There's quite a bit of welding on this, and when you're welding around this smaller diameter tubing, changing your angles can be a bit of a challenge, so sometimes it's nice to just let off your pedal periodically and reposition. I'm going to MIG weld the steering arms onto the steering shaft here because it has a bit of a mill scale to it and it's relatively thick. Now to weld the bottom, I have the engine mounted on here, so rather than removing it and flipping it over, I'll just practice welding on my back. Now I can install a floorboard. I've just cut this sheet metal to size, and I'm going to hold it in place with these pony clamps. If you don't have any of these metal spring clamps, it's really one of the best things you can get. They're about $1, and I just pull the little rubber ends off of them, and they hold things in place. I'm just MIG welding this because the plasma cut edges and the light mill scale on this floorboard is a little more tolerant to that without a lot of cleanup. I'm also just going to tack my pedal mounts on with MIG. Next, I want a cover for the torque converter here to be able to keep it protected. I made a full video about building this, but I actually built a wooden buck for it out of some thin plywood on a laser cutter. You can find that full video on my channel, but basically I used that form to be able to bend some expanded metal around, then cut and welded it together. Once the hoop was made, I'm able to add a cap on the end, and I'll just weld at each point that the expanded metal hits it, and hope for the best. I think it'll work out okay. It fit on really nicely once I finished that, so it's going to give a nice look that's a little bit more in line with the vintage style than the stock factory one. Next, I'll turn my attention to the actual sheet metal for the seat, and I cut out the shape that I need here. I'm just driving it around trying to chase off the water. I could have just as easily cut that out by hand with the plasma cutter or even with a jigsaw, but it's a little faster and more precise with the CNC. I'm going to go ahead and put a bend in it using the swag brake here, and that's just going to make it a little bit more rigid, being all one continuous piece rather than having the brake at the back. But the challenge is making sure that this is actually going to fit. Did I measure right? And it seems to fit pretty well. With the sheet metal for the seat welded in place, I can spray on a little bit of red paint. I decided to go with a bright cherry red because it's a good fit for this style of vintage kart, and I think it really pops, especially once I install all the black accessories. Let's reassemble this.